All right, so let's go over some answers that you might have come up with for this so far. So why do you think the people in the video got stronger? So I said that maybe they just thought the drink would make them stronger, and so they felt stronger, and maybe that led them to work harder. And that's why they actually seemed to get stronger after they drank the drink. I want to do my own similar experiment. So here is my initial plan. I'm going to measure everybody's initial pulse rate. I'll give each student some caffeine, some Coke, and I will wait for a specific amount of time, and then I will measure their final pulse rate, compare the final and initial. So what are some issues with my design? The first thing is, and you could have said other things, but these are my three. So the first one is there's nothing to compare the results to. So I don't know that it was truly the caffeine that increased everyone's pulse rates. Maybe we were just having so much fun in class together that everybody's pulse rate just went up because it was so much fun in statistics. So there's other things that could have happened to raise pulse rates rather than just the caffeine. Another thing is the sugar could be the variable that is increasing the pulse rate. So sugar sometimes can increase your pulse rate, make you hyper, and so there's another thing because sugar is in Coke that could affect somebody's pulse rate. And then people know they are drinking caffeine, so it could get in their head. So just like with the energy drink in the video, people know that caffeine is supposed to increase your pulse, get you caffeinated and excited and awake. And so that might happen just because they're thinking about the fact that they are drinking caffeine. So now let's go back and propose some solutions to these problems. So the first one, the fact that there's nothing to compare it to, for this, I might want to create a control group. Because now if I have a control group, so one group that doesn't drink any caffeine and another group that drinks the caffeine, then I can compare their final heart pulse rates and see if the caffeine had an effect or maybe it was just the class itself. So that's in a control group. For the sugar, what you might want is control groups for other variables. So, sorry, can't thinking right. So, for the initial control group, I might want some people that drink caffeine, some people that don't. But now that I have other variables like sugar, I might want some people to drink sugar without caffeine. So to set this scenario up with a different type of control group, maybe I want to pick some people that don't drink anything, some people that drink caffeine, and then some people that drink maybe caffeine-free Coke. Because then they're still getting the sugar, but they're not getting the caffeine. So we could see if it's really just the sugar in the soda that's increasing pulse rates or if it really is the caffeine itself. And then the last one, remember, this is an example of the placebo effect. So with the placebo effect, it's that whatever is happening, the treatment and the experiment is getting into people's heads. And so just the fact that it's happening is causing a change. And so a way that we can eliminate this is by something that's called blinding. So in blinding, we are blinding the experimental unit, so the people in our experiment, as to what the treatment is or which one they are receiving. And this works really well with the Coke example because when I have regular Coke and caffeine-free Coke, if everyone is drinking some Coke, it's really hard for them to tell whether they got the caffeine or the caffeine-free. So without telling people which one they have, this allows for blinding to happen. All right, so go ahead and pause the video here real quick and try number 4. Just fill in on your own paper what experiment you might design in order to test the effect that caffeine has on heart rate. All right, so maybe now you have your experiment. I'm going to create mine. I'm going to say that we take the students and we randomly split them into 2 groups. And you can always do more, right? We could do like a full-on control group that does absolutely nothing. But for this, because we're going to have blinding, it's okay to just do 2 groups. So I'm going to give one group regular Coke. And the other caffeine-free Coke. Then we will compare the change in pulse rate or heart rate in the end. All right, so I'm going to draw another diagram like we did yesterday for this experiment. So I'm going to start with let's say we have, my biggest class is 30 students. So let's say we take the 30 students from, we'll just say first period. So 30 students in first period. I'm going to take those students and I'm going to perform random assignment. And when we talked about sampling, we talked about different ways that we can randomize. So you're going to pick one of those ways and you are going to create random assignment for every student. And they're going to be assigned to either group 1 or group 2. And that's all they know so far, group 1 and group 2. So I'm going to have about 15 students in each group. And then I'm going to give them their treatment. So group 1 gets treatment 1 and group 2 gets treatment 2. And that would be the Coke. So let's say that treatment 1 is the caffeine and treatment 2 is no caffeine. And then in the end, we come back together and we're going to compare the change in heart rate. Now, some important notes here. Make sure that your groups are roughly equivalent. So if we did this in 6th period with only 19 people, right, I'd have to have some uneven groups, but I want them to be roughly equivalent, as close as I can get. And then notice the treatment number 2 with no caffeine, this would be considered our control group. And now we've got an experiment that has a randomized design, and so it would probably do a good job of testing the true effect that caffeine has on heart rate. All right, let's move on to the important ideas for today. So our first important idea, learning target number 1. We have been talking about a lot of different vocab today, so we're going to make some notes about that. The first being the control group. So a control group is used to provide baseline data for comparison. So baseline data It kind of gives us a starting point. If nothing were to happen to anybody, this is what we would expect. So now we know that when we do apply treatments, any change from that comes from the treatment itself. So that's what a control group allows. The next one is blinding. And this helps with the placebo effect. So when subjects, and this is a single blind, or actually let's say and/or, because it could be both. Experimenter and this is double blind. I'll explain this in a second. Let's write it down first. Who interact are unaware of what treatment is given. So in blinding, you can blind either the subjects or the experimenter or both. So let's go to the example of testing the Coke with the class, right? If I don't tell you as the student and as the experimental unit whether you are getting caffeine-free Coke or regular Coke, I have blinded you. Because now you don't know what's happening to you. That is considered a single blind. I have blinded the subjects. Now I could also blind the experimenter. So that would be me. So maybe I take the Coke and the caffeine-free Coke right next door to the teacher next door and I say, will you please fill up half of these cups with caffeine-free Coke and half of them with regular Coke, and then bring them back to my room in 2 separate groups and don't tell me which group is which. Now, me as the experimenter, the one that's making you drink the Coke, I also don't know which group is getting caffeine and which is not. So now I am blinded as well, and that is considered a double blind. So you can blind multiple people when you are doing experiments. All right, and the last one that we're going to say right here is the placebo effect. And this is when a fake treatment so this is the placebo, works. And so a fake treatment does not have to be something that is purposefully fake. So when you talk about studies in the medicine world, a lot of times they will do, sorry, I should have said experiments. When you talk about experiments in the medicine world, they'll do experiments with pills, and half of the participants get medicine and half get a fake pill. Or with a shot, half of the people get the real shot and the other half get an injection of saline. And so that is purposefully a placebo as a control group. But the placebo effect can happen as well when it's something that we are trying to test if it has an effect. And that might be a little bit wordy and confusing. But for the Coca-Cola example, there could be placebo effect even though I think that Coke impacts your heart rate. There still could be a placebo effect because you could, just by drinking it, increase your heart rate because you're thinking about it. So placebo effect does not have to be something that I force to be fake. It's more of a fake feeling. Again, I know that's kind of hard, so if we need some more clarification with the placebo effect, let me know. We can go over it again. It helps me a lot if I'm explaining it to you in person. I can kind of read your faces a little bit better to see which parts we should go back over. So we'll definitely talk about this again tomorrow as well. Learning target number 2. This is when we are conducting random assignment. So why is random assignment important? Random assignment is important because it helps us get rid of some of those confounding variables. So in this example here, first period students come to school and a lot of them come in with a soda or a coffee in hand. Everyone's tired. They want some caffeine on their way to school. So half of the students in first period might have already drank some caffeine, and now I'm about to give them even more. So that is another confounding variable that could affect heart rate. But if I perform random assignment, so if I take all the students and I randomly assign them to one group or the other, then theoretically, it's possible that there is a mixture of students who did or did not already drink caffeine this morning. And so therefore, because it's random and it's equally as likely that you are in either group, that confounding variable is not going to have such a large effect. So basically, I need to do random assignment. The first thing I'm going to do, just like we did with sampling, is to label. The second thing is to randomize. And the third is to assign. So basically exactly what we did before, except for instead of select, now we assign to a group. All right, and last, learning target number 3. This is going to be important. This is the 4 key principles of experiments. The first key principle is comparison. And I want 2 or more treatments. So with an experiment, I need to be able to compare the treatment with another control group. So either I do the treatment to one, I don't do anything to the other group, or you could have multiple groups where one group gets no drink, one group gets caffeine-free soda, one group gets caffeine soda. And really, you could start to create multiple groups, but now the more groups you get, the more confusing it might become. So you're going to say 2 or more. Most likely, you'll use 2 most of the time, but there might be a few cases where it's really helpful to have more than 2. All right, the second principle is random assignment. So again, just to reiterate, when we do these problems, there are confounding variables that are going to affect different people's responses. And when we perform random assignment, we create a way to lessen the effects of the confounding variables. So while your morning coffee is going to affect your heart rate, everyone else in the class, their either early morning coffee or not early morning coffee is going to balance out with yours. I don't like how I said that. Um, Let's say you drank a coffee, your neighbor also drank a coffee. It's likely that you could be split up into two different groups. Let's say half the class drank coffee. It's very likely that there will be equal representation of students that drank coffee in both group 1 and group 2. There we go. All right. Key principle number 3 is control. In the control, we keep all other variables the same, besides the treatment constant. So in the control group, I keep all other potential variables besides the treatment besides treatment's constant. So for my control group, I want everything else to be the same besides the thing that I'm trying to test. So in this Coca-Cola example, we are testing the effect of caffeine specifically. It's not just the effect of a normal Coke. We just happen to use Coke to give caffeine. So if I want to keep all other variables the same, then I would give the control group that caffeine-free Coke, because that keeps it the same that you are drinking a soda. It keeps it the same that you are drinking the sugar. It keeps all the ingredients that you are putting into your body the same, except for the caffeine. And then the key principle number 4 is replication. And so for this, we're going to say using enough experimental units to distinguish differences. So for replication, I want to make sure that I have a group of experimental units. Remember, experimental units are the who or what that we are giving the treatment to. So in this example, if I were to do this experiment with you guys, you would be the experimental units. And so I want to make sure that I have a large enough group of experimental units in order to distinguish the differences between my groups. And the reason this is called replication, you can kind of think of it like this. Did the data we collected show enough examples that if you were to repeat this again, you would get similar results? So essentially, did you get enough data that you know that what you have was not just a fluke, right? It's possible that one person just reacts very weird to caffeine. So if I do a group of only 3 people in each group, if even just 2 of them react really weird to caffeine, then that is going to really skew my data, and it is not likely that this is actually going to represent what's happening. Because if I were to replicate what I'm doing right now, I could get totally different results. So when my group is so small, it's really hard to imagine that they would represent the whole population. So I need to make sure that there is enough people that I can tell the difference that the treatment I am applying is making. All right, so that's all for today. Continue on to the Check Your Understanding, and if you have any questions, let me know on Remind, or you can join today's afternoon Zoom tutoring.